Here's how to solve a quadratic equation using the quadratic formula. The solution to the quadratic equation ax squared plus bx plus c equals 0 is the following, sung to the tune of Pop Goes the Weasel. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now let's see what it looks like to use that formula to solve a quadratic equation. Given the equation x squared plus 3x minus 10 equals 0, first thing we want to do is identify a, b, and c. A is the coefficient of x squared, which is 1. B is the coefficient of x, which is 3. And c is the constant term, which is negative 10. So plugging those into the formula, x equals negative b, so negative 3, plus or minus the square root of b squared, negative 3 squared minus 4, times a, which is 1, times c, which is negative 10. And that's all divided by 2 times a, which is 1. Now, using PEMDAS to simplify that, negative 3 plus or minus the square root of 9, and negative 4 times 1 times negative 10 gives me a positive 40 all over 2, or x equals negative 3 plus or minus the square root of 49 over 2. X equals negative 3 plus or minus 7 over 2. Realize that that is two equations. X equals negative 3 plus 7 over 2, and x equals negative 3 minus 7 over 2, or 4 over 2, which is 2, or negative 10 over 2, which is negative 5. And those are our two solutions. Here's another example. 11x squared minus x minus 3 equals 0. A is 11, b is negative 1, and c is negative 3. So x equals negative b, so a negative, negative 1, plus or minus the square root of b, which is negative 1 squared, minus 4 times a times c, all over 2 times a, which is 11. X equals 1, plus or minus the square root of 1, and negative 4 times 11 times negative 3 is a positive 132, all over 22, or x equals 1, plus or minus the square root of 133 over 22. And since the square root of 33 is not a whole number, the square root of 133 is not a whole number, I leave my answer in this form. It's funny looking, but it's correct.